meter reading. His work includes IoT products such as RF mesh system, GSM GPRS gateways, smart meters, and data concentrator units. So right now he is delivering the lecture. So welcome, Mr. Vivek ji. So let us start, and thank you every member who has joined our webinar.
Okay, over to Vivek Mittal, sir. Please.
Yeah, thank you everyone. Thank you very much for giving me opportunity to give the same webinar over this respectful institution. So okay, so as Santosh sir already introduced me, but okay, I'll brief about me a little bit also. So I'm Vivek Mittal, and I work in Cyan Connaught Private Limited as a senior embedded manager in research and development for various embedded product development, wherein I mostly worked on IoT products design and development, which mostly integrate with the smart energy meter, and we collect data through various devices and send over various protocols, wireless protocols to the server to make the meters and the infrastructure smart. Okay, so we'll proceed for the discussion on the embedded systems. If in case any issues, please interrupt in between. Okay. Okay, so today we will going to discuss on the content wherein we will discuss what are the embedded system. So basically, we'll discuss on the definition of the embedded system, what that consists of, and what embedded systems components will have in layer, so that everyone who can design or develop the various embedded products or designs, so that would be helpful by this basic knowledge of this webinar. And also we'll discuss on the challenges while designing the products, what challenges we used to face and how to mitigate these challenges, and how to make the products useful for the rest of the world. And obviously the application also will discuss what are the future trends, like today as we see in our world, all the products and are full of the embedded world, like whatever products we see around us, it's based on this technology only. And we'll discuss a little bit on the software development tools and their applications, how we can develop and the systems, and then we'll conclude this word also. Okay, so moving our the first topic, what are the embedded systems? So basically, as I already said, that the complete world is full of the embedded products only. If you see around us and you use day-to-day day-to-day life, we are using various embedded products like Bluetooth or smartwatches and laptop, meters, IoT devices. All are based on this technology only. So what basically embedded system is a special purpose of computer that use inside of a device. Like this is a device where we have the intelligence to work with our the certain hardware and the certain software. So based on the requirement, we design the hardware, and on top of this hardware, we write our software in form of embedded C or whatever it is, and we deliver the end product and as per our requirement. So this is our embedded system, which consists of the hardware and software. It's a complete package of this, right? And if we talk about the component of the embedded system, that would have the first of all, I already said, it would have the hardware. So both hardware we basically are used in our embedded developments are mainly first of all we have to use a microcontroller. So microcontroller is nothing, is the main unit of our any embedded product. So that microcontroller will have the various peripheral ICs. So what are the peripheral ICs? So suppose the microcontroller can't work standalone. So it requires certain inputs, then it will deliver the certain output. So that is why it has to integrate with the various peripheral ICs. So for example, the microcontroller will have to integrate with the memories which we used to call EEPROM or flash. Microcontroller will have to integrate with the RTCs to check the real clock time. Then certain if our product has the RF devices or Bluetooth devices, the microcontroller has to integrate with the Bluetooth or RF also. Then if they are the cellular devices, then microcontroller has to integrate with the modems. So these all are the peripheral ICs around the microcontrollers. And on top of these peripheral ICs, we will have the certain hardware. Suppose the power supply unit has to integrate which power ratings that particular product has to design. So for that we have to design the PSU also, which also the component of the hardware. Then various circuitry on that. We have to integrate. We have to design the product on the PCBs, power circuit boards. So this is the component of the embedded hardware. Then we come to the embedded software. So which is the operating system. So every controller will have their own operating system. So most of the operating system, the mostly used is the RTOS, which is the real-time operating system. Apart from RTOS, also the microcontroller will have their own operating system. So, but to give an example, I'll discuss on the RTOS. So RTOS is nothing; it's a real-time operating system which commonly used in today's development for the embedded devices or developments. So suppose we have some task. So that task has to deliver in certain time period, and that the time period is designed or written already in the RTOS, which consists of the some scheduler, which consists of some semaphore, mutex. So all have their own significance and various architecture in the RTOS. So that RTOS is nothing, is the package of the software we are writing on the embedded hardware. So that is why the complete package of hardware and software will consist of the complete embedded device. Now I'll come to the device driver. So device driver is nothing. It's basically act as a glue to the operating system in the peripheral devices. Okay, now what are the peripheral devices? So suppose we have to work on the two different devices. For if I'll take the example of the two devices. Okay, so your computer will if we we have seen that or we are integrating our we are connecting our Bluetooth devices to the mobile phone. So the mobile phone is the one product and the Bluetooth device is the another product. So if so both are the peripheral devices. If we have to connect the both devices to work as a one product, so that is why we are using the device driver. So for that each devices will have their own device driver, so that they can integrated and they can work efficiently as a product. So this is what the device drivers comes into the picture in the embedded world. Okay, now the next component is communication stacks. So communication stack is the capable of the communicating to the external world. So suppose like to make to understand, I'll put it in a way. Now like to discuss and to talk, we also using some communication language. Suppose like currently I'm speaking in English, so everyone can understand the English language and can communicate efficiently. Likewise, in embedded system also to integrate two different systems, there is a communication stack we have to implement so that each device can understand efficiently. So a communication stacks could be the hardware communication and the software communication also. So the best example of the hardware communication was is SPI, I2C, UART, CAN protocol. So these are the hardware things. And apart from this, the various software communication stacks could be, for example, in our energy meter, we are using the DLMS protocol or some other protocols which consist of the full of the communication protocols, so that two devices can discuss and can understand efficiently when to integrate and when to design the any embedded products. Okay, and obviously the embedded application. So on any product, we have to design the applications to comply the certain requirements. Whatever the requirements we have to design their own embedded application on top of it. So this is all about the components of the embedded system, right? Okay, so 1 second. So this is basically tool chain for the embedded software. This is more, I'm going to bit technical on the designing of the embedded system. So first of all, we have to design the hardware. After designing the hardware, based on our requirements, suppose we have the certain requirements, and based on the certain requirements, we have already chosen the hardware and we have designed our the electronic board based on the embedded components. So on top of it, we have to write the software on it. So embedded, as I already said, that microcontroller will have their operating system. So on that operating system, we can write our own program to make the product working. So to write the program, we have to use some tool chain. So that tool chains, we can't write the program as is like we are speaking. So for that, we have to comply some certain rules for the writing program into the microcontroller, right? So we can write the program in either C or C++, or if more feasible, we can write the program in assembly languages also. So as computer word or embedded system understand one or zeros only. So that is why we whatever the program we are writing, it has to convert it into their own binary codes or hex code. So for that, we are using this tool chains. So tool chain, after writing the program, suppose we, for an example, we have written a program for the hello world, printf and hello world we have to print. So so for that, to compile this program, we have to use the compiler. So that what compiler does. So what is the program we have written, that compiler is converting to the program to the object files. That object files format, suppose we have that multiple .c files or multiple files. So each file has to each file has to compile and convert it into the object files using this compiler. Then after compiling each file, each individual files, we have to link, the tool chain has to link all the files to the link through the linker. So that, because in microcontroller we can't program each and individual files, we have to program a single file format, which is the end file format. And we used to program hex file format into the microcontroller, which has the hex codes or opcodes in there. So the linker file will link all the objects files, multiple objects files, hundreds of objects files. It link into the single executable file, which is commonly used in the microcontroller, which likewise the hex format. So in our microcontroller, this hex format we are programming to we can program to the programmer, and it sits under the microcontroller's programmable memory. So whenever the microcontroller starts, it takes their hex code as opcode, and in the instruction cycle, it executes the program, whatever the program you have written based on that. So this is the most commonly thing we have to we have to use while using or designing the embedded products or embedded development. So till now, what we have concluded, we have to use some certain hardware component on top of it. We have to write the program So for that we have to use some compilers and linkers, and then through the programmer we can program into the microcontroller, and our product will work likewise. Okay, so as I was talking about the part of the embedded system, so uh, okay, so in embedded product, uh, suppose we are developing any of the products, so we have to use some sensors so that we can it will sense and give the predefined output, so that our processor or microcontroller will understand. Then we have to use the memories, then we have to use the some arithmetic application use logics, application specific logics, timers, or A to D or D to A conversion, which is the analog to digital or digital to analog conversion. Like suppose some inputs are in analog and microcontroller understand in digital only, then we have to convert these analog to the digital, or to give the output we have to convert some digital to analog output. So for that each microcontroller will have their own A to D or D to A conversion also. And in current scenarios, as the market is very competitive, so all the microcontroller nowadays are coming very optimized for any certain requirements, and all controllers will have their own memory, will have their own RTC, will have their own RF stack hardware. So all are customized and we can use as per our requirements. So this is the some parts of the embedded system while designing the embedded product. Okay. So now moving to the next slide, the challenges. What challenges we basically are we can face and we are facing while designing these products in this and development. So first challenge is precise engineering in design. So what do you mean by the precise engineering and designing? So to design any product, we have we have to have some requirements. Based on the requirements, we have to design our electronics or electronics hardware. And on top of it, then we have to write the software of this. So so to comply this product to the requirement, we have to select the optimized hardware only. We can't we can't leave any requirement to as is, so that it will have the any issues. And suppose we have finalized our precise engineering design already, and later on the some new requirement has come, then we have to think it of that how we can conclude, we can use this new requirements into the existing hardware. Because once the hardware is designed, it's very difficult to change the hardware or change the software for the small requirements. So that we have to think optimizely, so that the same hardware or the same software can be used the next some couple of years, or maybe we have to analyze the future market also. So this is the most challenge. The second one is the cost. This is very most challenge in embedded world, because every product is cost um, eff- effective, and everyone is giving their own low cost into the embedded market, right? So if we reduce the cost, our quality will reduce. If we and we can't increase the cost to the certain requirements, otherwise our product will not survive into the market. So that is why we have to take the balance between the cost and the quality, and such that we have to choose our design efficiently. The third one is the performance. Okay, so performance is also very most important thing while designing any hardware, because the reliability and performance is challenging. Suppose like in embedded world, each product will have their own specification. Like that product will survive to the certain voltage. This product can survive to certain power ratings, can survive with certain temperature, and and every component will have their own life cycle also. So based on this, we have to think of, and we have to choose the products and components to give the high performance. And for that, suppose our product will have the warranty of the 10 years. So then we have to design the product more than that the warranty of the product, so that, and maybe the life cycle. So for that, we can use the some environmental testing also of the product, so that we can make sure our product will survive with the high performance and the reliability. For that, we have the whole chamber which by which it will test our product to the extreme temperature and the humidity and environment cases, and we can calculate the life of the product in the low days of the testing only. So, like, suppose in 1 month testing, we can calculate the life of the product, whether it would be 10 years, 20 years, or more. So, that challenge we have to, and that mitigation we can do likewise. Okay, the next one is a careful selection of chips. So obviously, I think I've already covered this topic. So based on the requirement and the market need, we have to select the chips, optimized chip for our design. And we have in the competitive world, we already have the optimized chips and microcontroller processor already. So out of them, we can choose accordingly. And obviously, efficiency also is the most challenging. So in short, the challenge is to provide the affordable, highly integrated devices meeting significant requirements, safely, security, reliability, availability, and the time keeping to the cost low. So this is the most challenges in the embedded world. Okay, then moving to the next slide. Okay. So I tried to cover some embedded applications already here. So we have the industrial robots, GPS receiver, digital cameras, wireless routers. So nowadays, if you see, there is lots of the embedded application around us, and we are already using these application, these products, like set-top box, gaming console, photocopy, ovens, washing machine, fridge, AC. So all have their embedded applications in place. And how we can improve and we can optimize the products. So we have to continuously work for the improvements and the environment friendly also. So based on the environment friendly, all of the products are the embedded will have their certain emissions also, and so that we have to take care of our environment also while designing the products. So for that, we have some certain certifications are already there in place. So we have to comply, and we have to check all the certifications before designing the products, so that it will be well friendly, environment friendly, and reliability. Okay. Okay. So I'll discuss on the certain applications here. So we do have the IoT devices and energy meters. So what IoT devices are? So they are nothing. The IoT devices will have the wireless or wired IoT things. To take an example, if we can connect our washing machine with our mobile application, and we can control the washing machine um, over the wireless protocols. So this is the IoT application. So for that, we can use a certain uh, protocols like UDP, IPv4, CoAP, MQTT, so, and Wi-Fi protocol, Bluetooth protocol. So these all have their own protocols, and these are the software thing. Based on this, we have to select the hardware to make the compliances. And we have the cellular telephone and telephonic switches also. For that, our mobile is the best example. And out of on above of this, in cars, you can see we have the GPS tracking system, wherein the GPRS and GPS will takes place at these cellular devices also. And then handheld calculators, household appliances like washing machine, televisions, microwaves, ovens, fridge, ACs. So they all have their own embedding software and hardware, and they are a best example of the embedded application. Yeah. Apart from this, we can see the multifunction wristwatches, wherein that the wristwatch itself will have their sensors so that our body heart rates or SpO2, the oxygen levels, they can measure with some sensors input, and they will display the outputs. So this is the very best example how the embedded products will used to work. So they take the inputs through some sensing elements and the process the data and give the output. Again, the medical equipments are full of the embedded electronics devices nowadays, and they are very significant work we have, like the industries are already done on the medical equipments to make easy of life for the medical treatments nowadays. Then programmable logics controller and is a application, one of the application of the embedded system, and measurement equipments like oscilloscope, logic analyzer, and spectrum analyzer. So these are the very beautiful example of the embedded thing. And this oscilloscope and logical analyzer are used for the embedded development also. Suppose we have to design some uh, circuitry, and therein we can track the signals using the oscilloscope, and we can uh, design and design the things using these inputs given by the oscilloscope for the certain signals, voltage signals or current signals. Okay, and spectrum analyzer are used for the RF development, so that all the spectrums in RF and cellular devices can be analyzed and can be used for the debug for the applications while designing. So they are very helpful tool while we design these products. Uh, uh, Multimeters are also one of the example while we are designing these products. Okay, so this is just a embedded globe, and all around the world we are using the various embedded products, auto, offices, medical and imaging, aerospace and defenses, industry, instrumentation and industrial automation, home, mobile, IP networks, wireless communication, and central office equipment. So everywhere we are using these products. Okay, so now I'll discuss bit on the future trends. So uh, so while designing on these products, we have to think it of the future of this technology also. So first, the future trends mostly, like nowadays the AI comes into the picture. So in artificial intelligence also, there is using the inputs of these electronics devices. So on that, the main concern was my main future trend is the security. So for that, we have to use we have to work on, and we have to think of the various encryptions so that our data security will intact, because while designing and while delivering product to the market, we have to think the negativity or the other impact of this product also. Nowadays as we are moving to the technologies, the security is coming to the main concern here. So for that, we have the various encryption protocols already in place, but it could be more. We can give them more emphasis on this the securities of this encryption securities on the products. Then we have the telemedicines or the futures trends. Bluetooth applications nowadays. Most of the products are coming with the Bluetooth compliances, Bluetooth devices also, and that these products will have their own very much futures trends. And obviously the in cellular markets, we can see we are moving first. We have moved from 3G to 4G to 5G, and we are moving ahead also to the next generation of these cellular technologies also, wherein we have the certain protocols we have to implement, and we can uh, emphasis on the future of this cellular technology also. And obviously in medical devices also, the new trends are coming, and how we can optimize our designs so that it will be very much helpful and very can be easily traceable to our treatment and medical trends treatments. Oh, and I would like to discuss on the robotic part also. Now, the robotics also becoming the future trends for these applications. Okay. Bluetooth has applications, as we have seen that everywhere, the most of the places in short range, we are using the Bluetooth most widely. So in mobile phone, through the mobile phone we can connect our uh, cars through the Bluetooth stick. We can control the camera. We can uh, connect the devices to our laptops through the Bluetooth, obviously. And apart from this, Wi-Fi also. These all are the comes into the RF technologies. Then we have the Bluetooth and Wi-Fi enabled printers. We have the MP3 uh, products, wherein we can connect our products to the various devices using this technology. Okay. Okay. Now I would like to conclude this webinar. So the world of the embedded system is a dreamer's paradise for unlimited possibilities. So as this is very uh, good opportunity to work on the embedded things uh, with a certain limitations and the challenges, but there are the very unlimited possibilities wherein we can work on the various devices or technologies in it. It makes controlling all the systems around just by simple gesture, and things responded to you as if it was some magic. A microprocessor are becoming smaller and cheaper. More and more products are becoming smart with microprocessor embedded them. So now I mostly discuss on the microcontroller, but we have the microprocessor also in our embedded world, wherein we can write our own operating system on the processor, and it can be used efficiently on it. So this is all about the things. Thank you very much. If you have any questions, I would love to answer.
There is a question I think someone has asked uh, uh, about what is telematics. Actually, other things, cruise control, telemedicine, security, and Bluetooth application are all are more or less known to majority. But about telematics, I think the question is need to be elaborated for that. And any example for telematics?
Okay. One second, sir.
Okay.
So basically, telematics are very good example in the vehicle tracking systems. Like nowadays, we are moving to the automotive vehicles things. So wherein that these telematics are being used most widely. So this is very good example in it.
You mean to say that vehicles are tracked through the tele connection or some
Yes, sir. Yes, sir.
same etc. Okay,
Yes,
so this geo positioning is the telematics. In fact, other words.
Yes, yes, could be, sir.
Okay, okay. And one thing is the embedded thing is I think embedded hardware means the things are self sufficient to operate on automation or with the some smart sensing, etc. And what about the IoT if it is connected to embedded hardware? I think this is the actual process which you were explaining earlier. The embedded thing is the hardware which is already available on the equipment or the sensor or whatever is the thing over there. And IoT is the remote sensing and remote control of interface of embedded unit. I think
Okay.
this is a little bit requires uh, clarity on the definition of embedded and IoT microcontroller.
Okay, sir. So IoT is one of the application of the embedded products, sir. So in that, to comply the IoT, so basically IoT is nothing, Internet of Things. So for that,
Yeah.
this requires some hardware also. Suppose we have to design IoT wirelessly. So over the wireless, we can use the Bluetooth technology. We can use the Wi-Fi technology. We can use the cellular technology. So
Right.
all have their own predefined hardware itself. So Bluetooth for Bluetooth we have to use the Bluetooth circuit. For Wi-Fi we have to use the Wi-Fi circuit over the Wi-Fi protocol. And for cellular devices over the GSM GPRS we have to use the some modems. And on top of it we have to use the GSM GPRS stack over
Okay.
it. So
Okay.
this is where IoT is also the embedded application wherein we would require both hardware as well as the software.
All right. All right. So I invite any of the listener over there in this group if any question somebody wants to ask the expert Vivek Mittal. HRP Yadav sir is there. He's thank you very much for joining, sir. And Gaurav Soni, I'm really happy to see both of you on this list of joinees. Anything if you feel like to ask from our expert, sir? Other members like Anil Joshi, Vasudevan, and Manika Verma, Puneet Saini, Sudeep Parmanik, Swasti Avasthi, Anupama, and Valema Suarez. Sorry, I'm not able to pronounce your name. And please ask anything if you feel like to get clarification from Mr. Vivek Mittal, sir. I think there is no question furthermore over this. So over to Santosh Kumar for your further taking over, sir.
You are in mute, sir.
Santoshji, you are mute. You are mute. Please make yourself unmute first and then speak, please. Santoshji, you are mute. I think. Now it is okay. Please
Yes,
go ahead.
yes, sir. So thank
are
you very
unmute.
much, all the part who has joined and who has listened, Mr. Vivek, and also I think these type of webinars are very valuable for Electronics and Telecommunication Division. And in future, we will also organize same type of webinars on other topics also. So I want to say all the participants to connect their network also and take advantage of webinars in Electronics and Telecommunication Division by the Institution of Engineers. So thank you, Vivek Mittalji, for delivering his technical lecture, and also thanking you all the staffs who have arranged these webinars, including Satpal sir and our secretary Pramodji. So this is from my side. If anything you want to say, so please go ahead.
Okay, Mr. Santosh, thank you very much for conducting this wonderful session. It is recorded on YouTube and it will be available to all the listeners in future also whenever they feel like to connect. And I hope we will be able to answer their question if they come on a later stage. So thank you, Vivek Mittal, and thank you our IEI team at Calcutta. It is we are satisfied with your arrangements and the things. So kindly I thank you everyone over here. So session stand closed now. So thank you very much. Thank you very much for Mr. Mittal and Soni Santosh Kumarji for taking all these efforts and to bring this nice topic of a telecommunication event. Thank you very much.
Welcome, sir.
Thank you,
sir.
everyone. Thank you, sir.
Thank you, sir. To the participants, our link will open till tomorrow midnight. If anybody wants to get your e-certificate, kindly proceed towards the
Yes, I think no one has given that option to get the participation certificate, which I have also seen over there. No one has registered for that. Even then, if someone wants to have this, I think 17 people were there from listeners outside. It will be good to see more numbers in future. So thank you very much, team IEI headquarters. For organizing this wonderful session. Thank you very much, sir.
Thank you, sir. So we kind permission, sir. We are closing the session.
Okay, sir. Thank you.
So,
Thank you.
okay, sir. We take leave from this. Thank you.
Okay.